So we're trying to figure out the center of mass of this ice cream cone, but we can save ourselves some work because by the symmetry principle, notice how it's symmetric. The x-coordinate of our center of mass is going to be 0. So we know m sub y is equal to 0, and so the x coordinate for the center of mass is equal to 0. Okay, so now we only need to find the y coordinate. Now we're going to use the additivity of moments, so we have to do it this by parts. So let's do the let's go through the triangle, and let's find the moment for the triangle. Okay, so to find the moment for the triangle, we need a couple things. So let's draw a little picture. So we need to figure out what the, so if I draw a little rectangle here, okay, so let me label this. So this is going to be delta y, and then here we have the distance from here to here. That's going to be y, and then the so what I'm trying to do is I'm trying to write down, figure out what the area of this rectangle is going to be. So to find that, I need to figure out the length of the rectangle. So I'm going to call this just b. Okay, and then what I'm going to do is I'm going to use similar triangles to figure out what an expression for b. So let me kind of draw this in a little bit. So I'm going to redraw this down here. Okay, and so let me fill in what I know. So I know this side is 6, and I have this right here. That's going to be b, and I know this side down here, well, since it's an equilateral triangle, this side over here is going to be 3. Okay, so then using the Pythagorean Theorem, then I know that right here this is square root of 27, or 3 square root of 3. So then let's use similar triangles here. So then I know that b over 3 is going to equal to y, which is right here, this section right here, right? That's just going to be y. So that's going to equal to y over 3 root 3. Okay, so then that means that b is equal to y over square root of 3. Okay, so then what that means is that the area of the this little rectangle is simply equal to twice b, so 2y over square root of 3 times delta y. Okay, so then the moment with respect to x is going to equal to the integral, and then this is going to be from 0 to the top right here. So this is 3 root 3. So from 0 to 3 square root of 3. And then this is going to be the area, which we just decided is 2 over square root of 3 times y, right here. And then the delta y, as delta y goes to 0, this is going to give me the dy. And then times the distance from the x-axis, which is also going to be, so from here to here, that's also going to be just another y. So this is going to be y squared dy. Okay, so simple enough. So this is actually equal to, if you do all the work there, this is equal to 54. Okay, so that's only for the triangle only. So now what I need to do is I need to do the semicircle portion. So let's do this right here. Let me make a little box here. So the semicircle. And then I'm going to add up both of the moments. So, okay. So let's do the similar analysis here. I've got my rectangle here. Okay. Now, this time, however, so let me write this down. So we're going to have, so here let me label this. So this is going to be my, this time this is going to be my y, right? So, but now the, my rectangle, notice that I need to figure out what this is again. Now, if I draw a line from here to here, that's the radius of the semicircle, which is 3. So what that means is that the half of the width of my rectangle is going to be the square root of 3 squared, which is 9, minus, and then the height of this triangle. Okay, now what's the height of that triangle? Well, the height of that triangle is y, right? The distance from the bottom to the top. This is y minus, and then we'll minus the triangle, so minus 3 root 3. So this is the square root of 9 minus y minus 3 root 3 squared. Sorry for the little getting in there so bunched up. But anyways, so then what I'm going to do is so that gives me the half of the width of the rectangle. So the length is going to be twice that. So I'm going to have 2 the square root of 9 minus y minus 3 root 3 squared, and then dy. So that's the area of this rectangle now. That's this. This is twice the length, and then times the width. That's this delta y here. And then the limits of integration, those are going to go... oh, wait, don't forget. So that's the area of this, but then also times the distance from the x-axis, which is y. So let me actually, let me put the 2 on the outside, and I'll just leave that room there for the y. So the y goes here, and then the 2 on the outside. And then the integral, I'm going to go from 3 root 3 to, and then 3, I'm going to add 3 to it because that's how far that is. So this is 3 plus 3 root 3. So this is a pretty complicated looking integral. So this is going to take us a little while to do. So why don't we make a little room here for ourselves. Okay, so I'm going to rewrite the integral. So I have 2, the integral, 3 root 3 to 3 plus 3 root 3. And then y square root of 9 minus y minus 3 root 3 squared dy. Okay, so let's try cleaning this root up a little bit. Let's do a substitution. Let's let w equal to y minus 3 root 3, and then dw is equal to dy. So then this is going to equal to 2 times the integral. Now, might as well change the limits of integration. Notice how they become quite a bit more complicated. Complicated. A lot simpler. Because when y is equal to 3 root 3, w is equal to 3 root 3 minus 3 root 3, which is 0. And then when w is equal to when y is equal to 3 plus 3 root 3, then w is going to simply equal to 3. So that cleans up the limits of integration. Okay, and then I'm going to have the square root of 9 minus w squared, and then dy is dw. And then here I have y, which is, if you solve for y here, this is w plus 3 root 3. So let's put that in. Okay. Now, why don't we break this up into two integrals? Let's distribute this. So I have 2 times the integral from 0 to 3 of w, the square root of 9 minus w squared, dw. And this is going to be a pretty simple one to do, integral, using substitution. And then plus 2, well, why don't we do, this is 3 root 3, so that let's make that 6 root 3. The integral from 0 to 3 of the square root of 9 minus w squared, dw. Okay, now, let me make a little bit more room here. Okay, so here we can do u substitution. U is equal to 9 minus w squared. Du is negative 2w dw. So then that means that this is equal to negative the integral of square root of u du. And this is going to be from, so let's change the limits of integration on this one as well. When w is 0, u is 9. And when w is 3, u is 0. And then if you want them to be from small to big, you can just use the property, change this to a positive, and then flip the limits of integration. So that would work quite well. Okay, and then this one, this looks like you're going to have to use trig substitution, but in reality, if you can use trig substitution, but looking at this, notice how this square root of 9 minus w squared, that's simply half of a circle of radius 3. And this, the integral from 0 to 3, that's simply the area underneath the curve, which is half a circle, from 0 to 3. So this is 1/4 of a circle of radius 3. So if I just use the, pi r squared, multiply by 1/4, so this is going to equal to 9/4 pi. And so then this is equal to, if you do all that, that's going to give you 18, and then plus 27 pi root 3 over 2. Okay. All right. So all of that was the moment with respect to x of the semicircle. Okay, so what was the point of that? Well, now let's do the rest. So what we have is the moment with respect to x is equal to the moment with respect to x of the triangle plus the moment with respect to x of the semicircle. And then we had the one for the triangle. If we go back here, that was 54. So 54. And then plus the moment for the semicircle, that's 18 plus 27 pi root 3 over 2. And so this is 72 plus 27 pi root 3 over 2 give a little bit more room here. And did we find the area yet? Let me go back here. So we still need to find the area of the entire shape, but that's easy, right? Because it's just, so the area is equal to the semicircle. So this is 1/2 pi times the radius squared plus the area of the triangle is 1/2. The base is 6, and then the height is 3√3. So this is 9 halves pi, and then plus 9√3. Okay, so that's the area. So then that means that the center of mass, so let's write it down right here. So the center of mass is going to be the x-coordinate, remember we said is going to be 0, and then the y-coordinate is going to be the moment with respect to x, so 72, plus 27 pi root 3 over 2, all over the area, which was 9/2 pi plus 9√3. Done. Whew.